Hey, everybody.
Hey,
Welcome to Serverless Office Hours. I'm one of your intrepid hosts, Rob Potter. Joining me today, your most intrepid host, Eric Johnson, at whom I was waving furiously during that beautiful music you just heard, but he was ignoring me completely.
did you like that? No, I saw you laughing at me.
That's
Just so we are very much twins, so I'm the one with the goatee. Other than that, we're pretty much like twins, so I do know that. And
and I'm the good-looking one.
yes, exactly. So,
Yeah.
welcome to the very first. Did you know this is the very first edition of Serverless Office Hours for this year?
Yes, 2021 is upon us.
It-
Let's
it-
tell the good people. Let's get right to it, man. Let's tell the
Okay.
good people what we're going to discuss today.
Yeah.
Hello,
All right.
hello, Santosh.
All righty. So here's what we're doing. So I'm going to bring up our little screen here.
Show
This is
me.
what we're going to be talking about today. So we're going to be talking about container image support for AWS Lambda. And I'm going to walk through several examples. First of all, we're going to learn how to kind of roll our own. Second of all, we're going to look at it with AWS SAM. And then we're going to look at it with AWS CDK. And that's just going to be the first half of the hour. And then we're going to kick into an Ask Me Anything. If you didn't see my tweet, I may not know the answers, but this man right here, he knows them all.
Yes.
Or we have a great team of developer advocates who are joining. We got Ben and Chris and James and Julian who are in the helping us out in the moderators. I can't talk. One of them needs to talk. It's not happening with me today, apparently. So yeah. So should we just jump in and get started?
Let's get after it. Like you said, I'm going to answer all those questions. They might not be right, but I'm going to answer them.
That's right. We're seeing a lot of hellos out there. Hello to all of you who have joined us. We're excited to see you. And with that, I think we're going to get started. Let me get my screen ready here. Woo.
Do it.
All righty. So I'm in my handy dandy Cloud9 IDE here that I'll be using. So if you've been in a cave and you're not aware, at reInvent this year, AWS Service announced container image support for Lambda functions. Now, what does that mean? So what that means is you're able to, so previous to this, you can use zip files, and they store zip files in an S3 bucket, and that's still available and works great. But also, you can now store your code for your Lambda functions as container images. And there's a couple things that come with this. And Rob, I'm going to actually bounce back to you while I get this ready. What are some of the advantages that come with that?
Bounce back to me while I drop this link in the chat
Nice.
to the launch blog announcing support for AWS Lambda functions packaged as container images. One of the things that this gives you, probably the biggest difference, the thing that this gives you that you cannot get with zip file functions is 10 gigabytes of space, right? So your container image or for your function can be up to 10 gigabytes. And this allows you to package in production, real world machine learning models, like very large ones, large data sets. If you're doing high performance computing and you want to shard your data set, package it into functions to process certain cases in like a Monte Carlo simulation. Really the big differentiator there is that disk space. And then there's the rest of it is sort of, well, you can do this way, but now you do it this way. You also get the control over that underlying operating system that you package up that we would be running for you before. So if you already have a pipeline for delivering base images and things like that, now you can take advantage of that.
That's right. Yeah, and it's advantage of the tooling, right? The container tooling, if you're already doing that, you can use that to obviously create your images for your Lambda functions as well. Yeah, I thought that was funny. So surely if your image is hitting 10 gigabytes, I don't know though. There's when you get into heavy dependencies, things like that, sometimes it gets a little crazy. So
yeah, and real world models. I mean, where's the line, right? Like TensorFlow models and all this stuff are easily 3 gigs. So should it be 5? But then next year that's not enough. For a large number of reasons, 10 just gave us the space. But you're absolutely right. In general, if you don't have a special use case and you got 10 gigabytes of stuff in there, you might want to think about what you put in there.
That's right. John Walsh says HPC workloads tend to get huge. That is very true.
Absolutely.
So, all right. So the basic idea here is you create a container image and you upload it to the ECR, so the Elastic Container Registry. So I'm going to show how to do that really quick. So what we're going to do here is I'm going to go ahead and we're just going to I'm doing this all mostly direct. I'll do some copy and paste. I'm not going to lie. I'm not the expert. I tend to fat finger a lot. 2 fingers, they still hit all the wrong buttons. So there you go. So we're just going to call this raw. Okay. So we're going to CD into there. And there's a couple of things that we're going to need first. We're going to need a Dockerfile because we're working with container images, right? We're going to need an app.js file because this is the source code. We'll make our package file. I'm going to do this in npm, or I'm going to do this in Node. So, and that should be all I need for the moment. Okay. So the next thing I'm going to do is I'm going to go ahead and initialize this. If I'm doing this with Node, I want to initialize this so I can, if I have any dependencies or anything like that. You can this is agnostic to any language you're using. So obviously, if you're using Java, if you're using Python, whatever, you would do Python to be requirements text. So I'm just going to do an npm init so that I can add this in. I'm going to take all the defaults for now, and then I'm good. So now I can add any dependencies. And so just so we have it, I'm going to do an install of AWS SDK. Now what it does is it's going to download that. And you saw how fast that was? That's the beauty of Cloud9 right there. It's going to download under there. And it actually installs it. But we don't need it to be installed. I just wanted the dependency in the package file. So you can see here, I've got my dependency of AWS SDK. I can lock that if I want to keep it there. Right now, I'm okay with saying above that. I don't even need the package lock file anymore either. So now in our app, so our app is just going to be a real simple file, and it's literally just going to return the event. So we're not doing anything real crazy with that. So let me open up the app file. There we go. So just quick, hey, here's the handler, and I'm going to return the event that comes in. It's our Docker file that we want to kind of get curious about, look at what we're doing. So in the Docker file, I'm going to show you. I'm going to show you, Rob. Are you ready?
Missouri me. Boom.
Boom. That just happened. Right. So what we're going to do here is in the Docker file, this is what's going to build our image, right? And what we're going to do is we're going to grab from the public ECR, we're going to grab the node image, the base image for Node.js. Right, and then the next thing we're going to do is we're going to copy into that. We're going to copy the app.js file that I just created and the package.json file, so that my application code and my dependencies file are in there. And then the next thing we're going to do is we're going to do an npm install. Again, depending on what language you're using, you might do a Python or a pip install of your requirements, whatever. And then the last thing we're going to do is we're going to set the command to run when this Lambda function is invoked. And you'll notice here, I call my Lambda handler, and in the Docker file, we're calling Lambda handler. You seeing the theme? Are you seeing the theme?
I see.
So, right. So now that we've got this is the basis or basic Lambda function code and image that we need. So what do we do next? Well, first thing is we need a repository to put this in. Right. So what we need to do is go ahead and create our repository. Now, there's all kinds of ways to do that. I'm going to show you the CLI way at the moment. I'm just going to paste this. Rob, is my code big enough, you think? Is that working?
I would blow it up just a little, buddy. I think
blow it up. Okay.
maybe twice.
No, I'm only going once. I'm only going once.
No, one more for the people. For the people.
You're not the boss.
Be customer obsessed.
All right. Okay, there it is.
There you go.
All right. So hopefully that's more readable to y'all. I blew that up a little bit. So here's what I've done. I've just done an ECR create repository. I'm giving it a repository name, and I'm telling it that all my tags should be immutable. There's some more commands that you can pass it, but this will create it. So yes, John Walsh says, I spied the AWS toolkit for Cloud9. You are correct, sir. It is in there, and we can cover more of that in a later episode. Okay, here we go. So we're going to hit that, and there it is. Our repository is created. Now, if you're not a Docker expert, to be honest, before we release this, I didn't use containers a lot. I do it more. Rob does it a lot more than I do, but I'm doing it more and more, but I don't remember all the commands. So what's really cool is when I create this repository, we're going to go over to my repository list here. You can see here where I created it. Right in there, they're going to give me the commands that I need. So I can come up here to the view push commands. And the first thing I need is I need to make sure I'm authenticated. While I use IAM to have access to create repos, things like that, if my client needs access to pull those images, right? So what I'm going to do is I'm going to go ahead and authenticate. Now, I'm using Cloud9. I haven't set this up, but we also have a credentials helper, an ECR credentials helper that I heavily encourage you to look at. But just so you
about to bring that up, buddy.
You were right ahead of you.
I've even got a link right here. Watch this. Boom. There's a link in the chat, but I want to give a caveat too.
Chris Mon's throwing me grief. Says I still need to zoom. Chris, am I good, or do I still need to zoom? Here, is this better?
Let's take up a collection and buy him better glasses.
Huh?
Yo, that's
okay. In the browser, in the browser. Okay, yeah, okay. So, that's a good call. So let me blow this up a little bit here. Yeah, okay. Chris sometimes doesn't know what he's talking about. Sharp dude there. All right. So
while you're fixing that, wait. While you're fixing that, we talked about this little aside. I'm gonna take us on a side quest. We talked about the public gallery for ECR images. If you're a partner, a service provider, for some reason you're creating public base images and logging into the public ECR, then you're going to have to enable and disable the ECR credential helper, or I'd suggest that you just not use it right now and use the commands that Eric's showing you right now. Right. But if you're an everyday user, that credential helper is fantastic. The link is there in the chat.
That's the only time I wish I had thumbs to do that.
Thank you for tolerating my aside.
Okay, back to the business at hand. All right, so the next thing we're going to do is we need to create a local image, right? Or a local, what do you call it? Version image? What do you call it, Rob? Yeah, image, yeah. So Docker build -t, hello. Image. Yeah, so here's what I'm going to do. So what this is going to do is it's telling Docker to use the Dockerfile and build it and build the path that we're in. And we're going to call this image hello raw, okay? So it's actually grabbing that and it's building it out. Don't worry about this red here. It's gone now. The red was saying there's some NPM that I probably need to update. So I'm not worried about that right now. So what this did is this created a new image called hello raw with the tag of latest. Okay. So the next thing we're going to do, following our commands here, is we're going to go ahead and tag that to match what goes out. And I'll paste it so you can see it better. Right there. So it's going to match the actual image, the repo and the image that we're going to push it to. So we're tagging, we're making a new image locally. We're not pushing it yet. We're just retagging it to match the repo. So I'm going to do that. That's done. And the very last command that we're going to do is the Docker push. So you don't always have to go back and forth to this, but this helps me a lot. So if you're curious, hey, how do I get stuff out there? Well, there you go. All righty. So then I can go here, paste that, and it's actually going to push that. And so there you go, it's pushing it out. Now, while that's doing that, this would have been the time for your aside, Rob. I'm just saying, maybe time that better next time so you can do your aside.
Hey, can I inject?
I've
an aside here?
Yeah, please go ahead. Please go. Okay. All right. So
that's what I said before.
Okay. All right. Gotcha. All right. So now we've got everything in place to create a Lambda function with a container image on our own. We roll it on our own. So the first we're going to show this is we're actually going to go into the console for the moment. Now, this isn't probably, I wouldn't suggest building applications this way, but it's a good way to look at it. So we can come in here, we can create function, and we choose the container image. Yeah.
Eric.
Blow it up.
Zoom that?
Blow it up. Is Chris yelling at me? I don't even want to look.
No. That's a preemptory blow it up.
Probably,
I can't see it.
Probably just lost half my salary for that. Chris is he's a stickler for that. So, all right. So the container image is here. Now I'm going to name it. So we'll just call it the raw hello. And we're going to go. Now here's where we get to go in and we say browse images. So I find the repo first. Okay. So the hello raw repo. And then the images are going to be listed. And there's my latest. And voila. We've just created a Lambda function using a container image. Yeah, I like that. Voila. So there you go. And that we won't wait. This is being created right now, and we'll probably move on. But this allowed us to run that development cycle of creating the local, obviously creating our local code, creating our local image, pushing it up to ECR, and then building. Now, this is not something that you want to do. This is not what you came here. That's right. That's good, Rob. But this is not what we scale. The console is a great way to learn, great way to look at this, great way to make modifications. But when we're building applications, we really want to use infrastructure as code, right? We really want to use a framework that I can version, that offers me some local development tools, things like that. I wish there was something we had that would do that for us. Rob, can you think of anything?
If only there were such a creature.
If only. That's right. So we're going to do this with, according to our agenda, the SAM application model and the SAM CLI.
Oh,
so
is that a recursive acronym there?
Boom. I have no idea what that means. I'll look up recursive and then let you know. All right. So let's jump out of our little raw folder. So we're going to cd. I like to say my commands as I do it. When I get to a password, if you guys could plug your ears, that would be great. So here we are. Now we're going to build. Now we're going to build a serverless application using container image support for AWS Lambda, and we're going to build it with AWS SAM. So I am using, just so you know, the latest, I believe, 1.17, but sometimes they slip one by me. So this is 1.17. And so it's just simple. We're going to say SAM init, and we're just going to use an AWS Quick Start template for the moment. And then instead of choosing zip, which, like I said, you still have zip, and that works great. But I'm also going to choose image. So I'm going to choose 2. Okay. Now in my list, I'm going to choose. I'm going node. Look at that, JS 14. Look at that. I'm gonna do it. I'm gonna go 14. So alrighty, and we're gonna say SAM. Hang on a sec here. We'll just do the SAM app. Which I could have just taken the default there. Did you see that? I like to retype things. Okay, there we go. So now I'm going to CD into SAM, and let's take a look at what we have. So here is a full structure of hello world. Here's our Dockerfile. This has to look familiar to y'all because we saw it earlier, and I'm not going to lie, I copied it and used it in my raw setup. And then you can see here, I'm building the same thing. I've got code. Now this is set up. This is actually the default hello world. This is using. And we'll go to the template to show you. This is using the API gateway here, and it sets up. This is actually a REST API, and then it adds something different. If you're familiar with SAM, you have this wonderful metadata now that says, "Hey, here's the Docker tag." So it's going to use that to help tag the image. Here's the Docker context. This is where it lives, right? And here's the Docker file. This under this Docker context, it looks for Dockerfile. And so when you're using this, when we use SAM build, it's going to invoke that Dockerfile and build out our image for us. So I could tell you about it, but let me just show you. All right. So okay. So I'm going to say, hang on a sec here. I'm going to make sure it doesn't show I'm in the right directory. I'm not. Let me go into CD SAM app. Here we go. There we go. All right. So now I'm going to say SAM build. Now here's what happens. When we hit SAM build, that was fast. Now, Rob, you want to take a guess why that was so fast?
For those of you who are fans of the Little Blue Truck series, that's one of the lines from it, which is why I chuckled. My toddler loves that. That was fast. I would guess that it was fast because of newly released features in AWS SAM CLI. Would I be correct in that guess?
Yes and no, but not yet. So it was fast because it already knows that we had downloaded that image when we did the raw, right? So it has already locally cached using Docker. It locally cached that image. So it grabbed it and did it, right? So let's look at this here, and we're going to actually, and you can see here where it did the it grabbed using cache. There it is. So it uses cache, stuff like that. So I'm going to go ahead. Now, one of the cool things with SAM is I can do a simple SAM local hello invoke. There we go.
SAM local hello. That's a new one for me.
You like that? It's the now see down here. It says message hello world. I'm able to test very quickly my local environment, and that's just invoking the Lambda function directly. I almost said Lambda without function right there. That was bad.
Hey Eric. Hey Eric. When you run that locally, is it running a different version of what you'll run on AWS, or is it running the actual exact same container image that you'll be running on AWS?
Exact same container image. Ta-da! I thought that was I was waiting for you to go wrong. I thought that was a loaded question. So
just teeing you up, buddy. Just teeing you up.
So let me show you something else cool. Can I show you something else cool?
Show the people.
I'm going to do it anyway. So yeah,
the people want to be shown.
That's right. So I'm going to go into a lot of this code is already built out. Like I said, I'm not even going to lie. I'm not even going to try to say, hey, I'm building this totally by hand. I like to test everything first. It's always a good idea. So we're going to go into my file here, and I built this more of a complex application. All right. So in this complex application, this is probably more realistic of what we're building. The code's still very simple, but let me go to my template real quick here. And it's so big. So in this template, I'm declaring 4 different Lambda functions. Okay, I've cleverly named them 1, 2, 3, and 4, much like I did my 5 kids. So, and you can see down here that I've built out the Docker context. The other thing I did is I changed them from using a REST API to using an HTTP API. So we're able to use that. Now, one of the cool things I can do is I can say, are you ready for this? I'm going to blow your mind. You ready for this? So first of all, I'm going to do a SAM build, and I'm going to say cached. So I want it to use any cached images if available. Now, that's not the Docker cached images, because it'll already check for that. It's your code. If your code hasn't changed, it won't rebuild that. Yeah, I like that face. The other thing I'm going to do is I'm going to say, if I spell this right, Rob, did I spell that right? Parallel?
Yes, you
I'm going
did.
to tell them to do it in parallel.
Thank you for using the full.
Did you
link.
Yes.
I noticed and I appreciate. I see you. Thank you.
I appreciate that. So now I'm going to hit enter, and you can't see a thing. So I'm going to scroll up here. It built all that already, and it looked for cached images, and it built them. Let me pull it so you can see it. It built them at the same exact time. Right. So instead of saying, because it used to be the same, you'd say build this, then build this, then build, and you may want that. So that's obviously in there. But now you can say you build them all at the same time. So I built those in parallel. So now what I can do if I go in, so I'm going to go into 1, and I'm going to change this real quick here. I'm going to, all right, and I'm going to say hello from Lambda 1. How are ye? Okay, I like that. How are ye? Okay, so I'm going to save that. Now I need to build this in order for me to get the latest version. So I'm going to say that again, say and build cache parallel, and only the one function. You're only seeing one here. One function rebuilt. Okay, so it's a much more effective way. Now here's the fun part. So now I want to test these. Okay, so here we go. I'm going to say SAM local start API. And then here's the fun part. I'm going to say warm containers. I'm going to say do it eager, meaning load them all up right now. Ready for this?
I would have named this SAM local microwave. Because I think that's the most eager way to get your containers warm.
Which is so cool how you totally displayed why we don't talk to you about naming. So thank you. I appreciate that. So, all right. So now what I'm going to do is I'm going to bring up a new terminal and clear out this whatever I broke there. So I'm going to curl. Let's see what I'm going to do here. So I have 1, 2, 3, and 4. So 1, 2, 7. We'll just copy this. I'm going to copy.
Everybody hit those endpoints as fast as you can right now. Everybody just DDoS Eric's app on localhost.
They're local, Rob. No. Rob's new to routing.
They're in the cloud.
Right, so I'm going to hit this. Okay. And there's our answer. And you saw it has the new one. So now I'm going to hit it again. Now, if you remember using SAM, did you see how fast we got that back? It's using cached versions of this. So I can say, let's hit 2. And you get automatic responses rather than it having to spin up the container again. Voila. So if you're testing locally, build your client, and this is you can actually point your client at this 127.0.0.1 or Rob's machine on the same IP address, and you'll be able to test your backend server from your client. So SAM's great for using that. And then I can also, I can clear that out and still use the same local invoke like I did before. So let's clear that out. So I can say SAM local. Spelling count, Rob. Local invoke. And then I'm going to say, now, last time I didn't put a name. That's because SAM knows that there's only one function. I should only do one function. But I need to give it this one. So I'm going to say the one function. Again, cleverly named by me. This should work. Let's see. And there you go. So that's a quick way to test them as well. So there you go. That's building it with SAM. Okay, we're gonna as fast as I can. I'm gonna show you how to do it with CDK. We're gonna.
Hey, let me interrupt.
No. All right, go. Yeah,
I'll get. we've got questions coming in, and they're very good questions. I promise you we're not ignoring you. I'm capturing them for the second half of this when we answer questions. So if you don't see your question getting answered right away, don't worry. We're paying attention. We'll come to them and spend as much time on them as they need.
Awesome.
And please keep asking them as well.
I believe the rest of our developer advocates are out there answering a lot of these as well. So yeah, thank you, team. So, all right. So this last part, we're going to jump to the CDK. All right. So now CDK, I have to do this a little differently. I'm going to actually make the directory first, and I'm going to call it the CDK app, like so. And then I'm going to CD into that. Okay. All right.
This is uncharted territory for me, so I'm just going to.
All right. Okay. Nice. So now what I'm going to do is I'm going to do CDK init. Okay. And I'm going to give it a language, and I'm going to do TypeScript because that's as closest to Node as I can get. So I'm going to hit enter. Okay. And it's going to build out everything I need. All right. We'll give that a second here. Again, another reason I love to use Cloud9 is because Cloud9 is already in the cloud, and so it has really fast pipes, so you get stuff down very fast.
I mean, it's right there in the name.
What's that?
It's right there in the name.
It is. Okay, so I'm going to go in here, and the file I care about. Now, I'm not teaching CDK specifically, okay? Because I'm not the one you want doing that. We're a whole team of really smart folks doing that. But we're going to go into this under the CDK app stack. All right. So what this is this is where I actually construct my application. Now the CDK outputs, just like SAM, they both output to CloudFormation in the end. So what we're going to do is with SAM, I use declarative templates. With CDK, I use code. In the end, they both hit CloudFormation templates for deployment.
It is the AWS assembly language, after all.
That is correct. So, all right. So the first thing we're going to do is we need to create. We're going to create our code files. So I'm going to create a folder. I'm going to make a directory a folder called Lambda. Okay. Yeah, I lowercased it. It's a file in there, so that'll keep me up tonight. All right. And then I'm going to say I need a couple of files here. Again, I need a Dockerfile. I'm going to need an app.js. And then I'm going to go ahead and do my package.json. Okay. So those are in there. So then what I'm going to do really quick here under Lambda is I'm going to go into the app.js file, and I'm going to I'm going to cheat and grab my code from my, I'm going to type it by hand. That's what I'm going to do. So hang on just a moment here. Oh, I've lost my app file. Give me 1 second, folks. Everybody hold on, please. All right, so we'll just copy it from here. Raw, it's the same thing. So we're just going to use the same code. You'd think I'd memorize this, but here's where
sweet Lambda function.
Yeah, here's where I fall apart. A lot of times I can't remember if it's export or exports. I'm not proud of that, but there it is. So let's close out some of these other ones so I don't go into the wrong file, because I know I will. All right, there's got to be a faster way to do this, right? Okay, so I've closed these out. This is our JS file. All it's going to do is return the event. And our Docker file, now our Docker file is going to look just like what we did before, because we're still doing the same thing, right? We're still creating an image to do that. Hang on a second, I got to open the Docker file if I want to add to it. So still going to copy the package file. There's a lot more I can do on this. Julian has a great article on how to pull in extensions and Lambda layers. And I can, if later we have time, I can show something like that. But this is a very straightforward Docker file that will build the Lambda function image. All right, so the last thing we need in here is we're going to get our package file. Okay, now rather than initializing, I'm just going to copy the package file over into here. And there we go. Same things. We have AWS CDK, AWS SDK, anything I want. I actually don't need, because I'm copying that from there. Just the SDK in this one. Okay, so we're going to close this out. All right, so that's the Lambda function. That's everything we need to get the Lambda function working. So back to our lib stack here. I'm going to bring this down so we can see it. And I'm actually just going to paste my stuff in here. And here we go. All right. And there's a couple things I'm going to need to import. Now, the way the CDK works is each thing that you're going to use, you import it separately. So you can see already that my it's not liking my stuff here. And actually, let me I didn't mean to do that. Just give me 1 second. So we're going to do this. We're going to grab my imports, copy, paste, fail on my part. All right. So we've got the imports.
I blame JavaScript.
I would. Yeah, always blame JavaScript. Good thing I'm not doing this in Go.
Hey.
What? Was that out loud? All right.
Rude.
That was out loud, but I love Go. I just don't know it. That's my problem. All right. So I'll walk through this file in a moment. We're not going to do a lot with it, but I'll walk through what it's doing. But first, I need to go ahead and install any dependencies I'm using. Okay. In this, I'm using HTTP API. I'm using Lambda, and I'm using the HTTP API or API Gateway v2 integration. So I'm going to install those dependencies. And while that's doing that, I want to walk through the file real quick here. So here I'm creating the application. These should clear out now that once I get that installed here. Okay. I'm creating the application here. Here's where I'm declaring my Lambda function. And this is really what counts, right? This is what we're talking. And there's a construct called a Docker image code. I'm sorry, called a Docker image function. And in it, you can pass for the code your Docker image code .from image asset. It's pointing to the folder Lambda, so it knows to grab it from there. Then I'm going to declare my HTTP API, and I'm going to add a route that says the path / the method, only method allowed on our HTTP method.get. Integration is a new Lambda proxy integration, and I tell it to point to that function. Now, if all goes well, we're going to close this and let it reopen and see if it cleans up. Yep, they're all there. Now what I should be able to do is I can say CDK, and we'll just do a diff here, actually a deploy. We'll just go ahead and deploy it. If I do a CDK deploy, hang on a sec, I'm in the wrong folder. Now let's try. No. We've got, I've done a module here. So what I've done probably is broken something somewhere. So I'm going to go over here because always have a backup. Here is the actual file. I probably just didn't get a module down because I was trying to copy and paste too much. But I want to, not sessions with Sam, I'm sorry.
Now, if you want to go back and fix it, you ran your npm install in your Lambda functions folder.
Did I? There you go. Folder. Okay. Yeah. So I'm not going to do that for the moment. I may fix it while we're doing the questions, but I want to go into the CDK app so you can see it. So same thing. That's probably what happened. So let's just go into that CD app, and I can show you. Actually, no, Rob, I think you may be right. Let's just try it. We're to the point where we're going to open it up for Ask Me Anything. I'm only 2 minutes over. That's not too bad. There we go. Now you know what's going to happen is I'm installing all that other stuff in the actual function. So I'd want to go clean that up. But let's try that. Okay, deploy. Boom. Good call, Rob. That's it. So once I'm helping. And I can change it. And so there, it's gonna run the role. You can scroll up here a little bit here. It's gonna tell you what's gonna build. So we're gonna build the Lambda function. We're gonna build the service role. That Lambda function is also gonna build wow, I'm jumping around a little bit, an API gateway. So there you go. That's how you do it in CDK. I don't have the repo up yet, but I'll be posting it. I will be posting this code cleaned up, of course, without the wrong dependencies added. But I will show, I'll post this repo so you have the copies of this. So with that, I want to open it up. Rob, you said we had a lot of questions to answer. I'm gonna take it back to you and I, and let's answer some questions.
So the GitHub repo question is coming up again. I would say ping us. If you're not already following us on Twitter, then we'll tweet it out once it's up and the code's in there. So definitely watch that. I'm going to work. Let me see if I can go back to this question. Does SAM local run under the same IAM role as it would when deployed? And I'm gonna take a stab at answering this one, and you can fact check me here.
Okay. Wrong. Sorry, I was just getting practice. Sorry, go ahead.
No, it doesn't. SAM local runs under the account profile that you've configured on your machine, which is probably going to be based off your IAM credentials.
And it's probably an admin.
Right. Right, typically. Yeah. Or some other policy. It might be the opposite if you're in a big environment. Your organization vended you some restricted credentials, but in actuality, in production, it's going to run with expanded access to logging, monitoring, observability, et cetera. So unless you explicitly configure a profile in SAM,
Yeah.
in SAM to mirror,
Emulate.
to assume that role, to do STS to assume role on that role, and with the permissions to do that? No, by default, it's going to run as whomever you're running it as.
So let me take that a step further. Rob, you're absolutely right. And that right there is why, why local testing, bottom line, test as much as you can in the cloud. Test as much as you can in the real environment. When I was showing, if we'd built out that Lambda function when I was showing you the local invoke, and it were calling a DynamoDB table, you can actually call that DynamoDB table from the local Lambda function to test it. But it'll have all these open permissions depending on your local role, as Rob said. So you always don't go from your desktop to production. I mean, that's a bad idea anyway, but don't go desktop to production. Go desktop to development environment that only you see, so that you can catch it. Go, yeah, no, that's just fine. Works on my environment.
Works on my machine.
So, yeah, exactly. So
yeah.
All right.
This is. I'm going to ambush you with a 100% Eric question. You ready?
Yeah.
You ready? You're going to get it in 7 seconds, I bet. Can you show how to add cached and parallel options to the SAM config Tommle file?
Ooh, like that. Okay, so let me go back to one of the original apps that I've deployed and grab a Tommle file. So yeah, so here is one that I deployed. Hey, how about I share?
You're not showing your screen yet.
I will. I always get it right.
I can see it, but it's like teeny tiny.
Yeah. Okay. So can you see that? Okay.
Yeah.
All right. So you have the settings under here, under your Tommle file. And if you're not familiar with the Tommle file, this is created the first time you deploy. All right. You can create it by hand if you want, but this is created the first time you deploy, and it saves parameters. Any parameters you pass in deployment or set can be saved in here. You can see I've got some different things set up here. So what you can do is you can say, I'm going to copy these parameters, not the first one. I'm going to go down here, and I'm going to say, hello. There we go. I'm going to say default deploy, but I'm going to change deploy to say build, because that's the action that I'm taking. So build here. So the default build parameter, I'm over 7 seconds, aren't I? Darn it, Rob, you shouldn't set expectations. But
it's a good answer. But you knew inside of 7 seconds.
That's right. That's right. So I can't spell inside of 7 seconds. Cached equals true. Parallel spelling. And when you're doing this, go ahead and spell it right. So I don't always do that. So there you go.
It's a recommended approach.
Yep. All right. What else we got? Can we show?
There you go. Yeah. So thank you, Dan NBA, for that question. Thank you. I forget whose question I answered before. PFailBR. Not sure how to pronounce that. There's one. This has already been answered, but I feel like it's really important for us to discuss because it'll encompass several things. So from Mahmoud Rahman, how can I make Lambda run my Docker container as a root user instead of an arbitrary sandbox user? Because I need to start some service inside the container that requires to be a root or sudo user.
I'll take that. Totally kidding. Go ahead. No, that was all you.
Really?
What root? I am root.
Yeah. And this gets down to sort of the it's not the same as running a traditional container image, right? There are container images as a packaging format, and that's what this is. This is the Open Container Initiative image format specification. And there's container images as a runtime specification, the Open Container Images runtime specification. And that's more analogous to this. That's how you run things at runtime. And it's not just users. It's ports that you expose. It's networks you connect to. It's volumes you mount. It's these types of things. At the end of the day, what you're doing here is unzipping a file system, right? Before we gave you the OS and unzipped your code onto it. Now you're unzipping everything top to bottom. And I've got a blog on this that I'm going to drop in here on how that works if you want more detail on that.
Nice.
But so the user that you're running as is somewhat irrelevant by comparison, right? You may be able to start that service. And this is where I need to go like monkey around a little bit. I would say to try, because you may be root inside your micro VM, which is yours only. And that's addressed in the blog post as well. So give it a shot, but there's a difference between the runtime aspects of the container and the format aspects of the container, which is what we're going for. Thanks for the question. I saw some more further down. how does cold start come into play for an 8 GB custom image file compared previously to Lambda native image files? And our colleague Julian did an excellent job of answering this. I'm going to read his answer because you may be viewing it in a different location. So cold starts are generally going to be the same between the two deployment options, and that's true. Container image layers are cached by Lambda during function creation, so it makes cold starts as fast as possible. Julian has a talk and a blog that goes into this, I think, as well, about how there's different cache points once you publish your image to ECR and tell Lambda that there's an update available. And it begins to pull it down as close to where it needs it to run in chunks, each of which are encrypted. This is also covered in the recent update to the AWS security for AWS. The AWS security overview for AWS Lambda addresses how those chunks are secured in the cache as they come down. So the short answer is all this stuff is pulled closer to where your functions are going to run so that it is there when they need to be invoked. And in general, even for those large image files, it should be statistically similar start times to what you see with zip files, even though the zip files obviously don't have 8 GB of data.
I am posting a link to get that security overview of AWS Lambda right now.
Yeah, and Julian gave a tip for optimization on the back of that as well. Common layers are cached more effectively. So this is one reason why we say, oh, the AWS Lambda provided base images are between 200 and 400 megs, and a lot of people see that and think, I'm going to use Alpine. The problem with that is that the AWS Lambda base images are cached everywhere. So it's actually a zero differential if you're using a container image built on top of that to pull them compared to 12 megabytes for Alpine. So don't go for false optimizations in here. And this is in that blog post as well. So the more common these layers are, the more common layers that you can use, the more likely they are to be cached closer to the runtime environment. You also want to put your most frequently changing layers at the bottom of your Docker file so that you change the layers above it less frequently. Because once you change a layer at any point, you've changed all the layers after it because there are destructive writes on a layered file system. This is in that blog that we posted in as well.
Good stuff. Good questions.
Yeah.
What else you got? I saw a question by
I need to get a link for that.
Okay.
Security white paper that I just talked about.
I'm going to answer this real quick. Can you use SAM method with Lambda functions that are not fronted by? Absolutely. Yeah, API Gateway is one of 16 supported event sources that SAM, I mean, there's a lot more than 16 supported in AWS, but SAM supports 16 different, we call them triggers or event sources for Lambda functions. And so, in fact, you can build with SAM, dare I say, a serverless application that doesn't even have a Lambda function in it. What? That's right. You can, yeah. And then we get into Rob's favorite. You know, I built here a while back. I built a URL shortener, and I'll throw a link into it in just a minute. That uses it does. I finally added a Lambda function to tally some analytics, but it doesn't use a Lambda function for any of the logic. It's all done at the API gateway level using VTL, everybody's favorite friend. That's what VTL stands for, everybody's favorite friend. And
the US in VTL is for user friendly.
That's right. So, SAM is a tool set that's used to build serverless applications. So it's not limited. Yes, most of our examples are API Gateway and Lambda functions, but we're working to change that. But where step functions, you know, Rob loves step functions. You can do a lot without ever just step functions. You can put API Gateway in front of it. You can invoke it some another way. So SAM's very flexible. It's used to build serverless applications.
Yeah, because I love links. I'm going to put a link in the chat to App 2025 because there's basically no Lambda functions. There basically are no Lambda functions in that code except for simulators, and the rest of it is all service integrated. So that's just to give you an example of how SAM is more than just Lambda and API Gateway.
So I'm throwing in a shameless plug. I'm going to throw in a plug here called to the SAM repository. Oh nope, that's the wrong link. Oh, fail. I'm going to do it again. I'm going to type a wrong link. Nobody should let me type. So this link I'm giving you is pointed to my Sessions with SAM repo, and in that repo is the URL shortener and other examples of using SAM for non-API. It's more than just API gateway and Lambda functions. So lots of examples in there, and I'm going to try to get that in here properly. So here's the repo, and then I'm also going to add there's a YouTube series as well.
Yeah. Hey, while you do that, Rune Boss asks if there's any plan to add a WebAssembly or WASM runtime to Lambda server side. So this is a good opportunity to talk about how easy it is to build custom runtimes with AWS Lambda, particularly when you're building them as packaging your functions as container images. Individual runtimes and plans and roadmaps and all that stuff, of course, that's all up in the air, but I'll take that feedback back to the product team that you'd like to build with that. For now, just as my colleague Ben Smith dropped earlier in here, the building your own custom runtime is a great way to do that. Ben has an entire series on doing this with PHP. If he's here and listening, it would be great if he could drop a link in the chat and I'll amplify it. Otherwise, I'm going to go out and look for it right now as well.
Yeah,
but the custom runtime will get you what you need right now today. Ooh. There's a good question that just came in. Did you see this? Did you see this?
I did
lets us talk about a couple of things. If a microservices application needs multiple Lambda functions, and it probably will, what is the best practices to use a SAM template for multiple Lambda functions? Eric, I would like to take the ECR side of this question, and I would like you to take the SAM template side of this question.
Sure. Do the ECR first, because then I kind of talk about how that's done.
So as we talked about, when you're deploying AWS Lambda functions packaged as container images, they have to deploy from Amazon ECR or Elastic Container Registry. You have two options. You can either have one registry for all of your functions, and they're isolated by tag, and the tag contains the function name and the version. Or you can have multiple registries, one for each function. Which you choose is largely a matter of opinion, unless if you have large underlying layers that are reused frequently, like data models, data layers, abstractions that are used across all of your functions, they will only get stored in that repo once, right? And they're referenced in all the other Docker files. Whereas, so that in your build pipeline or in the deployment pipeline as well, they've already been pulled once, and they're not getting pulled from here, pulled from here, pulled from here, pulled from here, et cetera. So the general, unless you know why you're going to do it the other way, I would suggest one application, one ECR repo to benefit from those caching aspects of it, caching and deduplication aspects of it.
Yep. All right. So I'm actually going to share my screen again and show this. I'm going to share my screen. There we go. So in the complex app that I showed earlier, it shows how to manage that in SAM. So if you remember, this particular application had more than one function in it. You have one function, two function, three function, cleverly named, right? Now, we could get into how big do we let this go, and we talk about, how do you break down microservices? Microservices is a set of Lambda functions that have a similar purpose. Individually decoupled, things like that, but they're similar purpose, maybe behind the same domain name, same route, something like that. So you can break those up. So this would live in one repository. When I deploy this, and I'm actually going to go show this real quick. If I can, I'll just go over to this terminal here. So I get a terminal that works. When I deploy this actual one, so let me go into CD. And then I think it's 3 complex. It's going to ask me, let's see, SAM deploy, and I'm going to do it minus guided. I don't ever type that all the way out, but Rob it's all tense.
I appreciate it.
You can also do -G, which now that you've seen that, I'm going to change it to -G.
Now that's just mean. That's just spiteful.
When I go in here, it's going to do a couple things. Okay, so it's going to, first of all, what do you want to name it? So I'm going to name it Complex App, and this is the name of the stack. This is the CloudFormation stack that's going to come out. Next thing it's going to ask me is the region, and by default, it loads the region that you have set as default in your profile. That's a new feature, and Rob and I were very happy to see that happen. Then here's where it says, all right, what image repository do you want for one function? Now I have a choice here. I can put, obviously I put a repo. I have to put a repository. But I can, for the next one, I can put, and let me just grab a repository and I'll show you what I'm doing here. I have another in my preparation here. I have another repo, or I'm sorry, application that manages all my repositories. So I actually manage in SAM, I create all the repositories that I want. Okay. So I copied those out. So I have the name. So I can go in and say, okay, for complex one, this is the repository. And so I can go over here and in that build, I can paste that here. Now that I have that, I can put the same repo multiple times and do what Rob was talking about, sharing one repository for the application. Or I could put multiple repo for each one. I can separate it out. There are some who would say that's best practice. So you want to decide, how you want to run that. It saves, here's the interesting thing about SAM, it saves the data to that Tommle file that we were talking about, the SAM config Tommle file. It does not save it in the template because when you're using SAM local, it can't point to you don't want it pointing to the image in the up on the cloud. You want it pointing to the local one you built. When you do the build and deploy process, it'll then update it to this repository that you've created. So that's how SAM works with that.
Just want to point out one thing. J Walsh 2ME, which I read as me. Multiple ECR repos also allow for more granular lifecycle policies. That's true, and also for differentiated IAM policies, if that matters in your workflow somehow. So like everything, this is going to be a series of trade-offs, right? So this is, for example, if you need that, that's one of the reasons to move away from a single repo for all the functions, depending on how your application is structured. And if you wind up there, then you'll know that you need to move. What about this one, Eric? I've been turning this one over in my head, and I'm like, yeah, no, yeah, I don't know. Can you publish? So you can't publish. The only place you can publish the container image, if I can be a little bit pedantic, is to Amazon ECR.
Right.
Can you publish a SAM template that includes an AWS Lambda function packaged as a container image to the AWS Serverless Application Repository? I don't know. I'm trying to think of what happens.
I believe I'm 97.3% that's a no at the moment.
What if your image was in ECR public?
No, it's not. It's more of the template style. We need to update to do that. I'm pretty sure you can't, but I'm not sure. I'm not 100%. So that's going to be something we'll need to get back to you on Old Blue.
Try it and see.
That's a hard.
Let us know. Try and let us know. I would imagine just like, so if you had Lambda functions before, they actually had to be staged in public S3 buckets that could be read, right? You had to package them up as zip files, make that object readable to the world to be deployed. So if this is not supported today, when it does become supported, I imagine you're going to have to do the same thing. Have a public repo on the gallery and reference
set,
and reference. Yeah, or I don't know if you can have a private repo that's open to everyone.
No, that's right. No, you're right. Yeah,
I don't know. This is, it's a new space and we're learning with you. So
all right.
Smoke test it. See what happens.
Yeah, exactly.
The wheels fall off.
Other questions? What do we got, Rob?
That's pretty much what I see in here. There's one question. Again, Julian's just killing it at answering all these questions. That's why I tend to move
Julian's
past
like 3 times smarter than Rob and I put together. That's the truth. And he has crazy cool hair. So
yeah, AKA of average intelligence.
Yeah.
No, it's not true. He's of above average intelligence. That was meant to be a self-deprecating insult at Eric and myself, not.
Yeah.
How does context reuse work? And Julian answered this one as well as anybody could. Context reuse works exactly the same way between the two, between packages as container images and packages as zip files. Once the function is deployed to Lambda, the way they run is identical, right? So the service itself isn't, once you're inside the function, how did I get here? It's not existentially aware of any of that. The context is the context for the event as well. It's the context that it's running in. So all of that is, the event is the data of the event. The context is the context of the invocation, right? So it is tied to the event that caused the invocation without being the data. It's the metadata around the event. And just as Julian answers here, there's no change at that point because you're inside your code.
We got one came in. Can I grab this one?
Yeah, put it up there.
Yeah. How does one plan for blue-green? I just did, Rob. I put it up. How does one plan for blue-green deployments for Lambda function front-ended by API gateway? So when you're doing this, most of your code changes. So it depends on where the change is happening. Is it a configuration change in API gateway? Probably not. Or is it a code change in your Lambda function? Probably so, because that's what we iterate against the most. That's where we change. So if it's case 2 where it's a code change, then you're going to use what we call a safe deploy, where and I'll post a link. I don't know if Rob, if you can find it real quick. It's on the YouTube channel, but it's CI/CD that I did at reInvent last year. But what this talks about is with the Lambda function, you can set a Lambda function to blue-green. You can say just, hey, flop it, and there it is. Or you can do some canary or linear deployments where you can say, look, 10% for 10 minutes. If everything's good, go. Or 10% every 10 minutes, something like that. And so it allows you to do that. If one Lambda function fails, the test, and you can do tests before it becomes public and after it becomes public. So you have pre and post testing. If one Lambda function fails, then it will roll back the whole stack. So that's a way to do it when you're doing those kind of deployments and the changes in your Lambda function. If you're making a config change in your API gateway, and I'll find it in just a second. We have a blog on this, but you can get API Gateway REST API has canary releases built in, and it's automated up to the point where you actually deploy the whole thing. So you can say, look, I want you to do 10%. If all's well, then you push a button to deploy it, or you can do linear. And like I said, we have a blog on it, and I'm going to grab that real quick. And Rob,
I got it.
I got it. Oh, you got it.
I got it.
You. So hopefully that answers your question. So there's 2 different approaches on where your changes. Again, it's most likely your changes are going to be in your code, but once in a while, especially if you're getting into some of the advanced features of API Gateway, throttling, caching, field validation, things like that, then you may be doing a lot of configuration changes, and you want to do those as canary releases.
Yeah. All right, I want to click through a few here real quick that are related. Again, Jay Walsh, to me, really see a nice data science use case. Agreed. And data science's rich cousin, high-performance computing workloads. I guess they're both wealthy. They're both well off. You know what I mean?
Doing all right.
They're doing all right. So related to that, why would you use a fat container and pack your data model in there, or a lean Lambda function with EFS? And Yao Fei 75, you answer your question with a very excellent answer right here, which is, for the latter, it has to run inside a VPC. So if you're not already running inside VPCs with VPC endpoints and routing tables and all of the associated complexity that comes with that, I think that's a reason, right? Just pack the data into your Lambda function, deploy it, and run it without having to go through and configure that. If you're already in that, but there are also other reasons. They're different use cases. The container image is, how are you sharding compute across a static but huge set of data? Pack that into your image. But are you computing and iterating over a large set of data that is updating based on other iterations, or could update mid-iteration, or is even doing memoization using EFS, or locking using EFS? Some of these, if you're using those types of patterns, there is no substitute for that in using a large image. And of course, you can use both, right? You can have a giant base model that's packed into your image, and then use EFS. Right, but doesn't change at all. but use EFS as semaphores, mutexes, and memoization so that you don't do duplicate processing. So
big words, Rob. That was awesome. Semaphore.
Yeah, I love me some memoization. I love
liked
me some
it, yeah.
memoization. I'm a big fan. Big fan. Don't do the same work twice, you know?
I make you look smart. All right, what else we got? I think we're actually at time. I don't know if there's any last questions we can grab here. But here's what I'm going to do. I'm going to go ahead and bring up my screen again because this is a weekly. Oh, it looks like Julian's saying something.
I want to hit something on this.
Yeah.
Julian is correct here, but a base layer of a container image can be shared between multiple functions. So you see how this just continues to branch based on your use case, right? Which is why we don't necessarily prescribe a lot. EFS, read and write, can be shared between multiple functions. That container image won't be the same, but the data layer can be baked in right after the base layer or whenever it's updated, according to how frequently it changes.
All right. So that is this week's episode of Serverless Office Hours. I really appreciate y'all joining us. Next week, we are going to be, Rob's coming back. We like you, Rob. We want you back. So next week, we're going to be talking about AWS step functions, automating operational tasks. A lot of goodness there. A lot of, hey, why am I doing this manual? This could be automated. And Rob and Ben Smith are going to be taking on this. And so we look forward to seeing you. Same place, same time. Yeah. And for me, I'm out. Rob, you have anything you want to say?
Thank you all for joining us. That's what I want to say. I hope you learned something. Thanks for being here. See you next week.
All righty. We're out of here.